Another example of verifying an identity. Again, it's not quite sure which one's messier, but I'm going to go with the thing that has two terms rather than one term and try to force the two terms into one. That's usually a lot easier than to take one and force it into two. Alright, so number one, I could change everything into sines and cosines right away, but I notice this square out here and I'm going to have to do a little bit of FOIL, and I really don't want to do it with a bunch of fractions. So I'm going to FOIL it out first and then change things into sines and cosines if I have to. So let's see, we're going to FOIL this out. So cosecant of x, oops, cosecant of x minus cotangent of x times itself. Alright, so cosecant times cosecant is cosecant squared x. We're going to get minus cotangent cosecant and another minus cosecant cotangent, so that'll be minus 2 cosecant x cotangent x. And then finally, negative cotangent x times negative cotangent x is negative, or positive cotangent squared x. Somewhere in my mind, there is a relationship between cosecant squared and cotangent squared. So let's see here. I know that sine squared x plus cosine squared x is equal to 1. And if I want a cosecant and cotangent out of this, I'm going to divide everything by sine squared x. Let's see if this helps us. So if I simplify, we're going to get 1 plus cotangent squared x, cosine over sine, is equal to cosecant squared, 1 over sine x. Alright, so I can always replace cosecant squared with 1 plus cotangent squared. Well, would that help us? We can replace cosecant with 1 plus cotangent squared. I don't see that helping us that much. Yeah. So I'm just going to kind of go on the way and see what happens. I'm going to change everything into sines and cosines. So this would be 1 over sine squared minus 2 over sine of x times cosine over sine of x plus cosine squared over sine squared. Well, at least the denominator is going to be the same all the way across. Each one of them is going to have a sine squared in it. So this is going to turn out to be 1 minus 2 cosine of x plus cosine squared of x all over sine squared of x. Alright, so now we have to look at it. We need a 1 plus cosine in the denominator. And right now we have sine squared, but I have a clue on how to deal with that one. And then I have this 1 minus 2 cosine x plus cosine squared x. That seems like a quadratic. So I'm going to see if I can factor the top and substitute the bottom so it's in terms of cosine. And I'll try to do them at the same time. The top factors, rather nicely, factors of 1 that add up to negative 2 are going to be 1 and 1. And they're both going to be negative, so it's going to be minus cosine of x minus cosine of x all over, and then I'm going to change sine squared x into its Pythagorean identity 1 minus cosine squared x, and realize that 1 minus cosine squared x is a difference of perfect squares, so I can factor that. So this comes out to be 1 minus cosine of x all squared all over 1 minus cosine of x and 1 plus cosine of x. And if I cancel out one of the 1 minus cosines of x's, we're going to be left with one of them in the top, one factor of the 1 minus cosine of x, all over, that one's gone, and we're going to be left with 1 plus cosine of x. And we've got, finally, to where we needed to go.